Welcome back, Mathcounts friends. Today's video, we have hot off the presses the 2025 chapter sprint round. It was just released by Mathcounts today, just a few hours ago. So we're going to be jumping in. Now, this video is going to be part one. We're going to be covering the first 15 problems, which are the easier problems in general. So if you want, you can run this video quickly or jump ahead to the next video if you're very confident in your ability to do the first 15. All right, let's jump right in. And I would encourage you to, if you haven't seen these problems before, pause the video at each problem and try to work them out. I'll put chapters in so you can skip ahead if you want to different problems. Okay, so this is problem one, and it says, what is the value of 2 plus 2 times 2 plus 2 times 2 times 2. So that's just 2 plus 4 plus 8, and that is 14. So we can put 14 up here. All right, we're off to a good start. Number 2 says the value of a word is the sum of the values of all the letters in the word. The value of each vowel is 8, and the value of each consonant is 5. So the value of the word happy is, and then they show you an example. Then they want to know, what is the value of the word math counts? Well, we need to count up the number of vowels and the number of consonants. So we've got an A, an O, and a U. That makes 3 vowels, if my count is right. That's 3 times 8 points. Just for the vowels, that'll give you 24. And then we got to count up the consonants. I guess that's everything else. How many letters are there in math counts? There's 6 plus 4 is 10. So that means there must be 7 consonants, which are each worth 5 points. That gives you 35 for the consonants. And so the total value of the word is just the sum of the value for the vowels and the value for the consonants. And so that's going to give you 59. So we got the answer for this one is 59. Let's go on to problem 3. This one says, what value of x satisfies x times y equals 36 if y equals 12? All right, so we have x times y, which is 12, is equal to 36. We can divide both sides by 12, and if we do that, we get x equals 36 over 12, which is equal to 3. So 3 is our answer to this one. All right, let's go ahead and take a look at number 4. This one says the fair spinner shown is divided into 5 equal sections. What is the probability that the spinner will land on a multiple of 6? Express your answer as a common fraction. Okay, so we've got these 5 equal sections. We've got to figure out which ones are multiples of 6. So I see 48, that's a multiple of 6. 12 is also a multiple of 6. And those are the only 2. So the probability of landing on one of those 2 is going to be 2 divided by 5, since there's 2 that are divisible by 6 and 5 total. So that's our answer, 2 over 5. All right, let's go on to problem 5. This one says Ed is 2 years older than Al. Okay, Ed is 2 years older than Al. This is 2. And Ben is 5 years younger than Al. Okay, so Ben is back here, 5 years younger than Al. How many years older is Ben? Oh wait, did I do that wrong? Ed is 2 years older than Al. Ben is 5 years younger than Al. How many years older than Ben? Okay, older than Ben is Ed, so we're going all the way from here up to here. So how many years is that? Well, it's just going to be 5 plus 2, which is 7. So we'll put 7 in for that one. Okay. Let's go on to number 6. Okay, sometimes they like to scare you by putting in these little symbols. You can just pretend it's a variable if you want, like an x or a y. It says if 12 minus heart, I'll just substitute x here, divided by 3 is equal to 1, what is the value of heart? Or in my case, x. So we want to know what x is. All right, we can just solve this. We can multiply both sides of the equation by 3. That gives us 12 minus x is equal to, let's see, 3, because I multiplied by 3. Now I can subtract 12. That'll give me minus, or negative x is equal to negative 9. And if I divide by negative 1, I get x equal to 9. So that's my final answer. You can pop that answer up here. Okay, number 7 says a rectangle has width of 10. Let's call this the width. And then the length of 15. And it says if each side is doubled in length, what is the area of the new rectangle? Okay, well, the area of this rectangle is 150 because that's 10 times 15. And the area, if you double both the length and the width, is going to be 4 times as big. So you can just imagine that there will be another 150 here, another 150 here, and another 150 here. So it'll be 4 times as big. 4 times 150 is going to be 600. I guess I'm not going to bother to write it up there. 600 is the answer here. Okay, this one says if Andrea randomly chooses 2 distinct elements from the set 1, 2, 3, 4, what is the sum of the least possible and the greatest possible products? Okay, so what is the least possible product that you can get from 2 of the elements in this set? Well, the way to get the smallest possible product is to take the 2 smallest values, since these are all positive. So that's just going to be 1 and 2. And 1 times 2 is equal to 2. That's the smallest product that I can get. That's the smallest one. So what's the greatest possible product I can get? Well, similarly, we need to take the 2 biggest values in this set and multiply those together. That'll be 3 times 4, which will give us 12, and that is the largest. So what does it want to know? It wants to know the sum of the least and the greatest. So we take 2, we add 12, and that gives us 14 altogether. So the answer to this one is 14. All right, let's move on to problem 9. This one says, for the function represented in the graph and table, what is the integer value of y when x is equal to 12? Okay, so you can see from the table and also from the graph that we are going, every time we go up 4, we're going over 6. And they want to know what happens when we get all the way over to 12. So that means we're going to be going over 6 more. And so we're going to be going up another 4. And so we started at -4. When we went over 6, we got up to 0. When we go over another 6, we'll get up to +4 up here. So the answer here is going to be 4. You could also work it out by, using ratios or similar triangles. But either way, it's not too hard. All right, let's take a look at this one. This one is about the volume of a sphere. It says a sphere is inscribed in a cube with an edge length of 6. Okay, so we've got an edge length of 6. And it's a cube, so the length, the width, and the height are all 6. What is the volume of the sphere? And they're helpful. They give you the equation, in case you don't know it. It's 4/3 pi r cubed. That's the equation for the volume of the sphere. All right. So we need to know the radius. Now, when it says it's inscribed in the cube, that means it's touching just at one point on each face, at the center of each face. It's just touching. So what that means is that if you were to draw a diameter of the sphere, it would go from one face of the cube to the opposite face. So that diameter would be 6 in length. That means that the radius is half of that. So the radius is equal to 3, and then we just plug that into our equation. So we got 4/3 pi, and then we got 3 cubed, and one of these 3's is going to cancel with this one. So we can change this to 3 squared times 4. 3 squared is 9 times 4 is 36, so this is going to be 36 pi here. All right, that's great. Let's go on to problem 11. This says if the arithmetic mean of all these 5 numbers, one of them is just given to us as x, the arithmetic mean of those 5 values is 10, then what is the value of x? I think the easiest way to do this is to think about what the sum of these is if the mean is 10. So if the mean is 10 and there's 5 numbers, that means the sum has to be 50, right? So we've got 15 plus 7 plus 12 plus 5 plus x. That all has to be equal to 50 when you add it all together. So we can subtract all of this stuff. How much is that? We got 15 and 12 is 27, and then this 12, that'll put us up to 39. So we're going to subtract 39 from each side. and that'll give us x equals 11, which is our final answer on this one. All right, let's go ahead and move on to number 12. This one says, this rectangular prism has integer edge lengths, and the three distinct faces of the prism have areas 35, 45, and 63 inches squared. What is the volume of the prism? Okay, so it's nice that they tell us that there's integer edge lengths, because we can basically start looking at the prime factorizations of these areas. So 35, we know that has to be the width here times the length. And then this 45, that's going to have to be, I guess, well, let's call this one the depth, I guess. And so that's going to have to be this depth times the width is going to have to be 45. And then if we look at the top face here, we've got 63. That's going to have to be the product of, this is the length, and this is what we call the depth. So we need to figure out these three values, the width, the length, and the depth, based on these products. So we have width times length is equal to 35, and we have depth times width is equal to 45, and we have depth times length is equal to 63. So what can be helpful here is to take the prime factorizations of these three areas. So 35 can be factored down to 7 and 5, which is nice because there's only two values. So one of those is going to have to be the length, and one's going to have to be the width. Actually, that's really great. And maybe right away we can just see that 7 is going to have to be the one that is shares a side with 63. So that's going to have to be the length. So this 7 is going to be the length, and that means 5 is going to be the width here. So now actually we're pretty much done here. We just need to figure out the depth. And we can figure that out from the depth times the length is 63. That's the depth times 7 is 63. So the depth has to be 9. Okay, the depth has to be 9. All right, so what do they want to know? They want to know the volume of the prism. Well, that's just the depth times the length times the width. You just multiply those three numbers together. So that's 7 times 5 times 9, which is 35, times 9. Let's see, 30 times 9 would be 270. Then you add another 45. That gets you up to 315 for the total volume on this one. All right, great. Let's move on to the next one. This one says, if only nickels, dimes, and quarters, I'm going to write N, D, and Q. If only nickels, dimes, and quarters are available, how many different ways are there to choose a combination of coins totaling 30 cents? Okay, so let's list out all the possibilities here. I like to start by thinking about the biggest value, how many of those there are. So what's the most quarters you could have? Well, the most quarters you could have is 1. And if you have 1 quarter, you can't have any dimes, and you have to have 1 nickel. So that's the only case where you have a quarter. So everything else is going to be 0 for the quarters. Now I go to the next biggest coin, and I say, how many dimes? What's the most dimes I could have? Well, I could have 3 dimes. And you know that once I set the numbers of quarters and dimes, that fixes the number of nickels. I don't actually have to figure it out. Obviously here it's 0 because that 3 dimes gives me my full 30 cents. But in problems like this, once you know the number of quarters and dimes, you don't have to actually figure out how many nickels there are if you don't want to. So maybe I'll go on and I'll say you can also have 0 quarters and 2 dimes, and then that'll give you some number of nickels. It'll be 2. And then you can have 0 nickels and 1 dime, which will give you 4 nickels, but I don't care about that number. And then 0 nickels, I'm sorry, I think I might have said nickels over here. 0 quarters and 0 dimes. And then you'll have a bunch of nickels. And those are all the possibilities, basically. These 5, we've covered all the cases that there are. So the answer here is 5. All right, only 2 more to go. This one says, each of the 20 small squares in the figure to the right has an area of 1 square centimeter. What is the number of square centimeters in the area of the shaded region? Okay, so you might look at this at first and say, it's going to be hard to compute the area of this triangle because I don't know really, well, it doesn't have an integer base or an integer height or anything like that. It looks like it's a little odd. You could use the shoelace theorem if you wanted, but that would be more trouble than it's worth in this case. The best way to do this is to compute the area of the whole rectangle, right? Compute the area of the whole rectangle, and then subtract off the parts that are not part of our shaded region, right? So that's, you could call that like using the complement, right? So you're going to subtract off this area, and you're going to subtract off this area, and you're going to subtract off this area. And the reason that works in this case is you can easily see the integer base and height of these three triangles along the edge, because they have all these 90-degree angles here because they go into the corners of the rectangle like this. Okay, so it already told us there were 20 small squares, so we don't need to compute the area of the rectangle. It would just be 4 times 5, but we already know it. It's 20. So we take 20, and then we subtract the area of these. So let's do A. Triangle A is going to be area 3 times 3 divided by 2. So that's 9 halves. And then triangle B over here is going to have 2 times 4 divided by 2. So that's just going to be 4. And then triangle C here is going to have 5 times 1 divided by 2. That's 5 halves. So let's see, how many halves do I have altogether? Let's see, this will be 8, and 9 is 17, and 5 is 22 halves, which is 11. So I have 20 minus 11, and that gives me 9 for the area that's remaining, and that will be the area of my triangle. 9 is my final answer there. Okay, last problem. This is the hardest one of the easy problems. It says, in a bag there are 12 purple. Okay, we've got 12 purple, 7 green, 11 blue, and 3 pink marbles. If you select 2 marbles at random from the bag without replacement, what is the probability that you will choose first a pink marble and then a purple marble? Express your answer as a common fraction. Okay, so it's best to do this one step at a time. Let's think about the situation when you first draw that first marble. When you first draw that first marble, there are 12 plus 7 is 19, plus 11 is 30, plus 3, 33 total marbles. And you are going to try to draw a pink one. Well, there's only 3 pink ones, so you've got a 3 out of 30. Did I say 33? 20, let's see, 19, 30, yes, 33. 3 out of 33 chance, or in other words, 1 out of 11 chance of getting that pink marble. And then you're going to next draw a second marble, and then you want that one to be purple. And it's an independent event, so you can multiply the 2 probabilities together to get the probability that they will both happen. I mean, it's independent. Actually, I guess they're not. Yeah, it's not necessarily independent, because it does depend on it depends on what color you get in the first one. But once you've selected and you know that it's pink, now we can compute the probability that the second one will be purple. So there are 12 purple, and there are 32 left after you have picked the pink one out first. So we just need to multiply these 2 together. So we can do some canceling here. We've got 11 down here. We can do some canceling here. This will give us 3 over, let's see, 8. So this will be altogether 3 divided by 88. And that's the answer here. Okay, I hope you guys enjoyed that video. Please come back and join me in the next one. I'll be putting a link to the description of in the description for part 2, so you can go and see the hard problems next. All right, thanks for joining, everybody.